All right, math students, we are in Unit 4, and if you are an 8th grader, you need to know about roots and fractional exponents. Roots. We actually already know about roots, right? Like the square root of 25. But fractional exponents, you're not allowed to do that. What is this 25 to the power of 1/2 business? You can't have a fraction exponent, can you? Actually, yes, you can. And I'm going to go one step further and not only say that you can have 25 to the 1/2 power, but I'm going to say 25 to the 1/2 power is the same thing as the square root of 25. An exponent of 1/2 is just another symbol for taking the square root of a number. So, the square root of 25 is 5, and you could also say 25 to the 1/2 power is 5, because 25 to the 1/2 power is the same thing as taking the square root of 25. And that kind of makes sense when you think about it, because 25 to the 2nd power, to the power of 2, means to square 25, and the opposite of 2 would be like 1 over 2, and that's doing the opposite of squaring, which is square rooting. Kind of cool. Okay, so if you have 49 to the 1/2 power, that's going to end up giving you 7. Why? Because 49 to the power of 1/2 is the same thing as the square root of 49, and the square root of 49 is 7. Alright, so if you have 100 to the 1/2 power, I bet you could figure out what that comes out to. Jot that down, give me an answer. Okay, so the square root of 49 equals 7. Because 7 times 7 is 49. Or you could say because 49 equals 7 times 7. But what if I had 3 cubed? Which is 3 times 3 times 3, which comes out to 27. And what if I wanted to uncube the 27 and get back to 3? Would I say radical 27? No, that's not going to work because that symbol means the square root of 27, but I'm not trying to unsquare the 27, I'm trying to uncube the 27. You see my problem here? Here's what I'm going to do. Notice I wrote the same symbol, but I put a floaty little 3 by the radical sign, and this is called a cube root, and it's like a square root, but it means to uncube the 27 instead of unsquaring the 27. So in math, there's more than one kind of root. There are square roots, and there are also cube roots, where you're uncubing a number. So what is the cube root of 27? Well, it comes out to 3 because 27 is 3 times 3 times 3. So when you uncube the 27, you're going to get 3. All right, then what if I had the cube root of a big number like 125? Cube roots aren't as easy as square roots because it's not as easy to find 3 numbers, a trio, a triple, instead of 2. So sometimes it helps to make a factor tree. Remember, a factor tree is where you take the 125 and you split it up into, well, I know it's 5 times 25, but then 25 can get broken up into 5 times 5. Oh, hey, look. 125 is 5 times 5 times 5. So therefore, the cube root of 125 must be 5. Why? Because 125 is 5 times 5 times 5. We just uncubed the 125 and got 5. Okay, what about the cube root of 1,000? Well, 1,000 is 10 times 100, and 100 is 10 times 10. So once again, we've got a trio, we've got a triple, we've got 3 of a kind, and that's going to give us our cube root of 1,000, which comes out to 10, because 1,000 is 10 times 10 times 10. Of course, this only works if you can find 3 of a kind. You can't take cube roots if it doesn't break down into 3 of a kind. Just like you can't take square roots if it doesn't break down into the same number times itself. Alright, here's another practice problem. See if you can figure out what the cube root of 8 is. All right, so if a cube root is written with the radical sign with a floaty little 3, are there other kind of roots? In fact, there are. You can have a 4th root, or a 5th root, or a 6th root, or a 7th root, or an 8th root, or a 100th root. Okay, in math, roots are like unsquaring something, uncubing something, or when you get up into higher numbers like 4th roots and 5th roots, you're going to be looking for 4 of a kind or 5 of a kind or whatever else of a kind you have. So, notice whatever root it is, you write that little number floating in front of the radical. And we call that number an index. And we call this format, we call it writing it in radical form. Okay, so you have a radical sign, but you have a little index number to tell you what kind of a root you're taking, whether it's a cube root, 4th root, 5th root, etc. Here's some notes on that. You can pause the video and just scan these over. If you want to write any of that stuff down in your notes, you can. One of the important things in here is when you take the square root of a number, you don't have to write the little floaty 2 in front of the radical sign, which you already knew because we never wrote a 2 when we were taking square roots before. Okay, so if you look at the last sentence there, to write the 4th root of 16, you write radical with a floaty 4 in front of it, and then you put 16 inside the radical sign. Okay, so what is the 4th root of 16? Well, 16 is 4 times 4, and 4 is 2 times 2. Oh, and the other 4 is also 2 times 2, isn't it? So, therefore, the 4th root of 16 comes out to 2. All right, try this one. The 4th root of 81. Break that 81 down and see if you can break it down into 4 of a kind. And once you find 4 matching numbers, you'll have the 4th root of 81. Okay, one more thing. We've got a 4th root, which is a radical with a floaty 4 in front of it. We also knew that 49 to the 1/2 power means a square root. So fraction exponents actually mean roots, don't they? So how would you write the 4th root? You're going to write it with a fraction exponent as well, but instead of a 1/2, it's a 1/4. Hey, that kind of makes sense. So let's see, fractional exponents are something that you can use for all kinds of different roots. Like 1,000 to the 1/3 power means the cube root of 1,000, or any number to the 1/7 power would be the 7th root of that number. So, what the heck do fractional exponents mean? And can you have exponents that are fractions? Sure. Fractional exponents are always going to indicate some kind of a root, either a square root, cube root, 4th root, 7th root, or some other kind of root, depending on what the denominator of that fraction is. Notice the numerator is always a 1. All right, let's see if you got it. Try to rewrite this in radical form. We're not going to use a number, we'll just use an x. Just rewrite that in radical form with an x. Okie doke, that's all we got. I know today was a lot of stuff for you to soak up. If you need to rewind this, rewind it. If you need to jot down any questions and ask in class tomorrow, please do that.